Hey everybody, this is Larry. This is me going Q2 of the bi-weekly contest 175, minimum K to reduce array within limit. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this one. So the key idea behind this one is that you have this property, right? You have this property that can be true or not, and you know, you write basically it's just this formula, by the way. I don't know, I would P where I just put K squared on the other side, right? And then you have this formula, right? And we have this formula. Then now we're trying to find the first instance of K, which this is true. And, you know, just kind of playing around big numbers, right? So if K is 1, then it's going to take, then this part is obviously very small. This part is very big, so it's going to be a big number. So you have you know, relatively, you can have a big number. And then if K is very big, this is going to be very negative. And this is going to be very small, right? Because if K is very big, K squared is very big. This is going to be very small because you just reduce the numbers. So it's going to look like a line that, you know, slopes down like this. And you're trying to find the first point in which it, it is less than or equal to 0, right? And that's basically the core idea. You know, maybe I should just draw it. I don't know. I have the technology, Larry. But yeah, that's kind of how I would think about it. And this is going to be monotonically decreasing as a result, right? If you kind of plot it out this way. Nope. Okay. Yeah. So basically, you know, you have, you know, this axis. If K is equal to 1, right, then f of whatever, K is equal to 1 here, right? And it's going to be a big number because minus K, you know, it's right? And then you have some line where it's going to, you know, this is K is equal to infinity, right? Because it's K squared, and you're just trying to basically find either the intersection point or the first index in which that's the case, right? And that's it. And, you know, from that visualization, it's pretty straightforward to do a binary search, right? You basically go, okay, well, you know, you take, how do I change the color? Oh, is this so confusing? I don't know how technology works, right? So you have here, right? And then you go, well, you know, this is positive. So if it's positive, then we want to go on this side, right? And then maybe this is half, and then, oh, this is negative. Then you go on this side. I mean, it's binary search. That's basically the idea. It's just that I had the drawing pads out, so I might as well, draw it, right? Yeah. And that's basically what I did. I have, you know, the lower bound is going to be K is equal to 1. The upper bound is going to be K is equal to max number. I just add 2 for no reason, really. But everything is a binary search, right? So I do a binary search here, pretty straightforward, because like I said, if good, you can think right about this in any other way, but I will, if good is true, it means that what the function that, and this is literally just this thing, right? If this is negative or 0, then we make the numbers smaller in our bound, including that in the inclusive thing. Otherwise, mid is not good, so then we want to increase that, right? And here, it's just about walking one step at a time. For x, if we're moving one target at a time, then you have this number. This is actually the integer way to do sealing of a division, and that's basically it. And yeah, and this is the formula they give you for the problem, right? The total minus target square, and that's it. That's all I have for this one. I mean, this is going to be linear, right? This function is linear, I mean, but obviously this is binary search, so this is going to be R this is of log R, where R is the range of the numbers, and already you can say is over B, where B is the number of bits to represent this, which is the same thing, incidentally. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest next. Right? Okay. Usually make a mistake. Can't tell. All right. Non-positive is the minimum number of every element non-positive. Okay. You can choose an index I and reduce it by K. Okay. Min value of K I mean, that sounds like a binary search thing, but okay. So why? Let's see. If we choose 1, then we reduce all of them by 1. But then this is going to be huge, and this is going to be 1. Right? If it's 2, then this is going to be smaller. So this is going to get bigger, right? So the function that you're actually optimizing for is this function, right? Minus k squared. Even though it looks like that thingy, and you want that to actually you don't want to minimize this. You just want to find out whether this is less than 0, and I guess if k is big enough, then that is going to be not true. If k is huge, then this is always going to be true, so it is binary search, right? I mean, I kind of knew it, but maybe I'm just being a little bit too careful. That's not the right upper bound. Yeah, I mean, it's just this bound, right? Or max of nums, maybe. I mean, I probably knew it. I'm just, I don't know. Am I being too careful these days? It's possible that that's true. Okay, so it's good if this is true. If this is true, then mid is a good value, and we want to try something smaller. Okay. Right. Yeah. So the number of operation is going to be equal to the ceiling of this, right? I guess I could have just I don't know. I like it because in theory you might have binary search in that dimension, but oh, really? Why? That doesn't sound right. Why would I binary search on 0? Oh, because max is 1. That's the only time, I suppose. No. What? I don't get it. I mean, I know I could just if statement it out, but I think that's a smell. 0, 1, so then this is... Actually, I guess that makes sense. Can it be 0? Maybe not. Because that would just be infinity anyway. Okay, fine. You win that time. So we'll just do it like +2, just because why not? YOLO submit. Okay. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.